Hello and welcome to the first real episode of Refactoring Bitcoin. Today I want to go over the C API of the Bitcoin kernel and get an understanding of all the types it provides and also about what the dependencies are between those types. And I want to turn that in the end into a class diagram. So the way I want to do this is I will go over the complete file, look at all the function declarations, and then see whether the function declaration represents a relationship, what kind of relationship, and I want then write it into a graphis file. So if we look at this function here, for example, BTCK transaction output get amount, it takes in a transaction output and it returns a number. So this is a built-in type. This does not really appear as a dependency in a class relationship diagram. But the function over here, where you cannot really see the name because of all this boilerplate, like Bitcoin kernel warn unused result. But if you remove that and also remove that, you see BTCK transaction output get script pubkey. So this takes in a transaction output and returns a script pubkey. And we can assume, since there are no other arguments to the function, that this is a true whole part relationship. So this is exactly the functions that we are looking for. But before we can, so to simplify the transition, we want to get rid of all this boilerplate. And to do that, I'm going to use the C preprocessor. I do not want to preprocess the standard includes, so I simply remove those includes declarations. In this Bitcoin kernel API section, I just remove all the lines except the one that defines it as empty. And also the Bitcoin kernel warn unused results. I just remove everything except the line that defines it as empty. And the same here. Get rid of that. Now I save the file, open a terminal, and now I step into the kernel directory, and now I invoke the GCC preprocessor with -e. That's the command line flag of GCC to invoke the preprocessor. Now also pass in -p, which tells it to omit line markers, should be just interested in the declarations. And now I tell it the name of the file, and I redirect the output to a file with the same name, but with the extension dot. So this is done. I close the terminal. I open this dot file, and I set the syntax coloring to C to get nice colors. I disable diagnostics, and we see in the file we have a bunch of type defs. We just get rid of them. We're only interested in function declarations. I also remove the type defs for function pointers, and I will also remove all the type defs for those structs here. This is just a bunch of structs containing callbacks. You're not really interested in those. It gets interesting here where the function declarations start. We also want to remove some boilerplate like this BTCK prefix. Let's just get rid of it entirely. We also want to get some more vertical space. So I replace all semicolons with semicolon followed by a new line. And in the end, I want to reformat the whole file. So now this is much nicer to read. So now I go over all the function declarations. The first function is transaction create. It takes in a buffer, but this is not something that is representing a relationship. So I skip this one. The next function, transaction copy, it takes in a transaction and returns a transaction. But as the name suggests, this is doing a copy, And copy is a normal operation of regular types. This is not something we need to represent in our class relationships. Then the transaction to bytes function, this serializes a transaction. It's also not something that we want represented in our dependency graph. So now the transaction count outputs function. We have count outputs and we have transaction get output at. So we get the number of outputs and we can get a single output with a specified index. So this is something that we want to note in our dependencies. We say a transaction has one or more transaction outputs. So we represent that as a edge in the graph. This is how we represent whole part relationships. This is done. We have the same thing for inputs. So we have get input at and we have count inputs. So we do the same thing. A transaction as a whole part relationship to, where is it? Transaction input. Done. Transaction get txid. So we say a transaction has a transaction ID. That's also a whole part relationship. Transaction destroy. This is the destructor. This is not represented in our dependencies. So the next type seems to be script pubkey. We have a constructor, which also just constructs a script pubkey from a buffer. We have the copy operation, we have a verify function, and we have a serialize function, and we have a destructor. So none of that is interesting in our dependency graph. You skip it. Now we have transaction output create. This creates a transaction output from a script pubkey and an amount. So we say a transaction output has a script pubkey. And since this is passed in the constructor, we want to add some special annotation. So we say style stashed. Good. The amount is not something that we represent as a relationship. The next function is transaction output get script pubkey. So this seems to be the accessor for the returning the script pubkey from a transaction output. So we can actually remove this declaration we added here. So and now it's represented like a normal whole part relationship with a getter. The transaction output get amount function is the getter for the amount. This returns a built-in type. So this is not something that we want to represent as a dependency in our graph. We skip it. Next function is transaction output copy. Again, it's a copy constructor. We do not represent it in the graph. And the destructor as well. Logging disable copy. This seems to operate on global state. Also the logging create function. It takes a callback, which is one of the function pointers we just deleted. It's not something that we represent as a dependency in a graph. We can remove all this logging stuff. The next function is chain parameters create. So this creates a chain parameters from a chain type. So we write down the dependency, chain parameters as a chain type, and we only pass it in the constructor. So we use the dashed annotation. Good. Chain parameters copy, again, a copy constructor, and the destructor can be skipped. Now we can create a context options out of thin air. Remove. Context options set chain params. So a context options has a whole part relationship to chain parameters. This is a setter. So we represent it as a normal edge. Next function is context options set notifications. So a context options has a, what is this? A notification interface callbacks. That's quite a long name, but since the function here is called set notifications, I just you call this notifications. So a context options has a notifications. Okay. Next one. Context options set validation interface. Again, a context options object has a whole part relationship to this. Again, is a very long name. And I notice there's a similarity in the naming convention. But this function is called set. This has this interface suffix. I don't care. I just call it validation. So a context options has a validation object. Context options destroy is just a destructor. Then context create, from context options, we create a context. So we say a context has a whole part relationship to context options. And since this is the destructor, the constructor, I also use style dashed. And we have a copy function. Here we have a function called context interrupt, which just returns a built-in type. So we skip it and we have a destructor. Now it gets a little bit more interesting. We have a function called block tree entry get previous. This is a little bit tricky, so I'm not sure whether this is supposed to be a whole part relationship or not, or what is this. Block tree entry has some kind of relationship, but I want to highlight that because this might be something that we want to rethink. We only want to have whole part relationships in our dependency graph. Now, block tree entry get height. This returns a built-in type, so we skip it. Block tree entry get block hash. So a block tree entry has a block hash. This looks again straightforward. Now we have a function block tree entry equals. It takes two block tree entries. Guess it compares them for equality. Checking for equality again is a very normal operation for regular types. So we do not need special annotation in our dependency graph. Then we have chain state manager options create. So we create a chain state manager from a context plus some strings, which are built in, not represented in the relationship graph, but the context is. And since this is a constructor, we again use the style dashed. Good. Chain state manager option set worker threads num, quite a long name. This is setting an integer on this chain state manager options object. It's not represented in our dependency graph. Then we have chain state manager options set wipe dbs. It's also not represented in the dependency graph. Chain state manager options update block tree db in memory. And chain state manager options update chain state db in, what is that? Chain update block tree db and chain state db. That's the difference. Good, but none of this is represented in the dependency graph. Then the chain state manager options destroy function is just a destructor. So we seem to have a new constructor here, chain state manager create. So a chain state manager is created from a chain state manager options. And again, since this is a constructor, we annotate this as dashed. Next function, chain state manager import blocks. This is a function. It takes a chain state manager and it seems to get an array of strings with a length, not something that represents a relationship. Chain state manager process block. Here we pass a block to a chain state manager. That could be a relationship. I mean, it certainly is a relationship, but we don't know whether it is a whole part relationship or something else. So we remember it as a dependency, but we also want to color it in red because this requires a second look. Then chain state manager get active chain. So a chain state manager seems to have a chain. Straightforward. Chain state manager get block tree entry by hash. Again, it's taking two types and returns one. So it's not clear whether this is just a whole part relationship. But since the block hash is, I mean, there is a whole part relationship. A block tree entry has a block hash. So I'm just assuming it can perform some lookup. So I can say a chain state manager has a whole part relationship to the block tree entry. That's actually okay. And this is a destructor. Now there's a simple function, block read. This seems to exchange a block tree entry for a block. But it's not clear who is that now. Does the chain state manager own the block? Oh, we already have the relationship noted. A chain state manager has a block and we want to have a second look. I share that opinion here. Okay, I can just leave that. Block create can create a new block from a buffer. Again, this is not something we need to represent in the graph. The copy function as well. Again, we have a count function paired with a add function. So this looks straightforward. A transaction has one or more. Sorry, the other way around. A block has one or more transactions, of course. Good. A block also has a block hash. And a block can be serialized. Fine. And a block can be destroyed. Also fine. Block validation state get validation mode. So we can get the block validation mode from a block validation state. This looks straightforward as a whole part relationship. Block validation state also has a block validation result. That also looks fine. Chain get height and chain get by height. So this one is not a relationship, and this one seems to say that the chain has one or more block entries like this. Fine. Chain contains, so we can get information whether a chain contains a block entry. Again, we already have this relationship right noted here. Then block spend outputs read. This seems to exchange a block tree entry with a block spend outputs. It looks familiar we had the same thing with block before. I'm wondering why this function is not over there. So I think a chain state manager, it's unclear what the relationship is, but I'm guessing this is a whole part relationship. But we want to have a second look. We say color is red, and I want to put this over there where we have the same thing with the block. Okay. Then we have block spend outputs, and just a copy. Block spend outputs count and block spend outputs get transaction spend outputs at. It's quite a funny name. But okay, this seems to be a block spend outputs has one or more transaction spend outputs. Actually straightforward. And a destructor and a copy constructor. Good. Again, a transaction spend outputs count and transaction spend outputs get coin add. This seems to represent a whole part relationship of transaction spend outputs to coins. So a transaction spend outputs has multiple coins. Okay. And a destructor and a copy function. Transaction input get out point. So a transaction input has a transaction out point, not to be confused with output, right? And the destructor and a copy. And now we have transaction output get index and transaction output get TX ID. So the index is not a relationship, but this one is. A transaction out point has a TX ID. Good. And the destructor and a copy function and an equal function and a serialize function and another destructor and yet another copy. We can all skip that. Now we have a coin confirmation height that returns a built-in type, so we skip it. Coin is Coinbase, also is just a built-in type. Coin get output, so a coin has a relationship to the transaction output. And we have a destructor, and we have a creation function for block hash from a buffer. We have an equals function, we have a copy function, we have a serialize function, and we have another destructor. So we can remove all that. So it seems like we have all the class relationships. We changed the syntax to dot, and I want to turn that into a directed graph. I call it G, and I close it down here. Hit save, and this is our dot file. Now again, I open the terminal, go to the directory, and now I invoke the dot tool. Dot, and I say I want to create a PNG file, and I pass in the Bitcoin kernel dot file, and I say the output should be Bitcoin kernel.png. That is done. I open the file, and here we have a nice class diagram. Remove the file browser. That is something nice, right? We can interpret right a lot here. The block validation state seems disconnected from the rest. So I'm assuming this is passed into the validation callback that we have over here. We see here on the left those dashed lines. This is where we pass things as a constructor. So it looks like this whole subtree over there containing chain state manager options context options, chain parameters, notifications, validation, and chain type. This is all necessary just to create a chain state manager. And I'm guessing the only reason for all those classes is that if you pass, for example, the notifications directly to the constructor of the chain state manager, that number of arguments would grow quite large. And this is not a problem in higher level languages like Python, where you could have named arguments, so it's clear which is which. But in a function like C, it's very tricky to remember the exact order and the exact meaning of the arguments. But this is something that we might need to rethink if we provide a modern C API. We may want to change that. Here we have those red arrows. This is something where we were not exactly sure what the relationships should be there. Yeah, but this is something that we will have a more closed look in a follow-up. For now, this class diagram is great. I hope you had fun watching and you learned something. And in the next episode, we start turning this into C++ code. Thanks for watching and bye.